So children, now we have understood what is an electrovalent or an ionic bond and what is electrovalency. Now we come to the next type of bond, a bond which is formed not by ions. These bonds are formed by mutual sharing of electrons. So like I told you, some atoms are not ready to give electrons. Who are these atoms? These atoms can be atoms of non-metals. These atoms can be atoms of hydrogen. These atoms can be atoms of carbon or silicon who has 4 electrons in its outermost shell. Then the type of bonds which are formed is formed by sharing of electrons. Two atoms come to an agreement that they will share the number of electrons which are missing from their last orbit. So let us see the example of HCl, hydrogen chloride. So hydrogen has 1 electron in its outermost shell. Chlorine has 7 electrons in its outermost shell. Hydrogen needs only 1 electron to complete its duplet. Remember, hydrogen and helium are allowed to be stable in their duplet state. Why is that? Because they only have 1 shell, and in the first shell by 2n square rule only 2 electrons can be accommodated. So hydrogen and helium are exceptions. They are happy with duplet state in their first orbit. So hydrogen needs 1 electron, but chlorine cannot give it that 1 electron. So what will chlorine do? Chlorine itself requires 1 electron. It has 7 electrons in its last shell, so it requires 1 electron. So what they do is, hydrogen and chlorine decide to share 2 electrons in all, which means 1 electron pair. Hydrogen gives 1 electron and chlorine gives 1 electron, which is mutually shared by both hydrogen and chlorine. As you can see, inside the shells there are 2 electrons. That means 1 pair is shared by hydrogen and chlorine to form that molecular bond or that covalent bond. Now you can see hydrogen, by sharing 1 of its electron, it got 1 electron from chlorine, so its duplet is complete. Same for chlorine, by sharing 1 of its electron, it got 1 electron from hydrogen, so it had 7 of its own, and now it has 1 extra electron because of the sharing with hydrogen. So both, by mutual sharing of electrons, by neither giving nor taking, just by sharing, both can come to a satisfactory duplet or octet state. We can say that they have achieved stability in a molecular state even without forming ions. So these type of bonds which are formed by mutual sharing of 1, 2 or 3 pairs of electrons. It cannot share more than 3 pairs of electrons. So the mutual sharing of 1, 2 or 3 pairs of electrons between any 2 atoms, the type of bond between them is called as a covalent bond. Alright, this bond is also called as a molecular bond. Let us look at some of the characteristics of a molecular bond, just like we did for our electrovalent or ionic bonds. So molecular bonds or covalent bonds are formed between 2 atoms. They are not formed between ions. They are formed between atoms. So they skip the ion stage. Can we say that? Alright. Covalent bond is a bond which is formed between 2 non-metals, because non-metals do not have a readiness of giving electrons. So when 2 non-metals have to form a bond, like hydrogen with oxygen to form H2O, hydrogen with chlorine to form HCl, carbon with hydrogen to form CH4, methane. These bonds which are formed between 2 non-metals, they are always and always covalent bonds. They are never electrovalent bonds. So hydrogen, can we say it combines with all non-metals in form of covalent bonds. Hydrogen combines with all metals in form of ionic bonds. Don't forget that. Alright. Covalency. What was electrovalency? Electrovalency was the number of electrons that were exchanged to form a bond. Covalency is the number of electrons that are shared to form a bond. Or we can say covalency is the number of electrons which are number of electron pairs which are shared. So what is the difference between them? So for the formation of HCl, hydrogen gave 1 electron, chlorine gave 1 electron, both of them were equally shared. Not equally, but they were shared, they were mutually shared, they came to this mutual agreement. So how many electrons are shared by each? 1. What is the number of pairs of electrons shared? 1. So what will be the covalency of HCl bond? It will be 1. So 2 electrons are shared, but the covalency will not become 2. Covalency will remain 1, because we either calculate the number of electrons shared by 1 each atom, okay, or the number of pairs of electrons shared. So if chlorine and hydrogen are each sharing one electron, we can't call the covalency to be 2, because the pair, how many pairs of electrons are shared? Only 1. How many electrons are shared by each of the atom? Only 1. So covalency in this case is going to be 1. Alright, so children, let us see the types of covalent bond. The types of covalent bond, the segregation can be done in 2 ways. The first way is based on the covalency. What is covalency? The number of shared electrons by each of the element, or we can say the number of pairs of electrons that are shared between any 2 elements. So based on covalency, either 1 pair of electrons can be shared, 2 pairs of electrons can be shared, or 3 pairs of electrons can be shared. So when 1 pair of electron is shared, or when covalency is 1, we call it a single covalent bond. Why is it a single covalent bond? Only 1 pair of electron is shared, like our example of HCl. Coming to double covalent bond. Double covalent bond is when 2 pairs of electrons are shared. That means totally how many electrons are shared between 2 atoms? 4 electrons. But covalency is 2, because how many pairs of electrons are shared? 2. And the third type is when 3 electrons are shared between 2 atoms. That means total 6 electrons are shared mutually, and 3 pairs of electrons are shared between 2 atoms. Is that clear? So when we see an example of HCl, when we see an example of chlorine, formation of chlorine formation of chlorine gas. Chlorine gas is Cl2. That means 2 chlorine atoms came together, both of them required 1 electron each, so they decided to share that 1 electron or 1 pair of electron with each other, and both of them achieved an octet state. Same we can talk about double covalent bond when we talk about an oxygen molecule or oxygen gas. Oxygen gas, think about oxygen. Oxygen has 2,6 electronic configuration. It has 8 electrons in all. So oxygen, each oxygen requires how many electrons? It requires 2 electrons to become stable. So now 2 oxygen coming together, they decide to share 2 pairs of electrons with each other and attain their octet state by a means of covalent bond. And what is going to be the covalency? 2. So this type of bond is called as a double covalent bond. Alright, coming to nitrogen. Now nitrogen has total of 7 electrons. So its electronic configuration is 2, 5. How many electrons does it need in its outermost shell? It requires 3. So nitrogen gas, N2 molecule, how will that be formed? When 2 nitrogen atoms, each of whom requires 3 electrons to complete their octet, they end up sharing 3 electrons each with each other and get a covalency of 3, because 3 pairs of electrons are shared. So by combining 3 pairs together and bringing them together, 3 pairs of electrons, that is total 6 electrons, by sharing them they form a triple covalent bond. Is that clear? So these are the only 3 types of bonds which can be formed based on covalency. There is no 4 covalent bonds or 4 covalency, does not exist. Covalency can either be 1, 2 or 3. That means how many types of bond can be formed based on covalency? Single covalent bond, double covalent bond and triple covalent bond. So kids, now let us go back to the concept of electronegativity. We defined partially electronegativity in our ionic bonds. What did we call electronegativity? What is electronegativity? The tendency to gain electrons is called as electronegativity. Why is it called electronegativity? Because when you gain electrons, you become electronegative. So that is one of the characteristics of being an electronegative substance. All right. So let us extend, or let us add some more to this definition, because this definition is only valid when ions are formed. What about bonds like covalent bonds where there are no ions which are formed? What about those type of bonds? How are we supposed to define electrovalency in that case? Sometimes, let's again go back to our example of HCl. So hydrogen chloride, out of hydrogen chloride, when they mutually agree to share that pair of electron with each other, what happens is, because chlorine has a high electronegative value, there are values of electronegativity, they are mathematical values. So chlorine has a higher electronegative value. And why does it have a higher electronegative value? Because it is a more electronegative substance. We found, based on many experiments, these electronegative values are defined. So it is a more electronegative substance. That means its tendency to get electrons is more. Tendency. Why am I using the word tendency here? Why am I not saying it's electronegative so it will gain electrons? Because covalent bonds are not formed by giving or taking electrons. They are formed between non-metals, where non-metals are never ready to give electrons. They are formed by sharing of electrons. But in HCl, this shared pair of electron goes a little closer to the chlorine atom. Why? Because chlorine attracts the pair of electron towards itself. So let me define electronegativity once more for you with the complete definition. Electronegativity in an electrovalent bond is when an atom takes an electron, correct? The tendency to gain electrons, completely gain electrons, is called as electronegativity when ions are formed. That is in case of electrovalent bonds. What about covalent bonds? In covalent bonds, in some covalent bonds, the substance which has a tendency of pulling the shared pair of electron towards itself. It cannot attract one whole electron. But when this mutually shared electron exists between hydrogen and chlorine, chlorine atom pulls the electron pair partially towards itself and gets a differential charge or a fractional charge. Now what is a fractional charge? Fractional charge is a charge that is less than 1. That means if I gain an electron, I get a 1 full negative charge. But if I don't gain electrons but only pull electrons closer to my field or closer to my orbit, I do not get the full charge, because full charge is only obtained when I gain the full electron. Now the electron is close to me. So when the electron is close to me, I get a charge which is partial, or a charge which I can say is lesser than 1. Is less than 1. It's a fractional charge. So once again defining it, electronegativity for ionic bonds is when a substance which has a tendency of gaining full electrons. But when we talk about covalent bonds, what is electronegativity? Electronegativity is a tendency to pull the shared pair of electron towards itself. We are nowhere mentioning that it gains the electrons after sharing. So there is no cheating involved here, that earlier they agreed to share electrons and now chlorine has taken both the electrons. That's not what has happened. It has only, so if 1 meter is the distance between, let's say, a chlorine atom and a hydrogen atom. That's not the distance. Distances are measured in picometers and angstroms. These are very small distances, but just for the sake of understanding, if 1 meter is the distance between hydrogen and chlorine atom, so they should be ideally sharing the shared pair of electron in middle, that is at the distance of 0.5 meter from both. But what happens is, this electron pair is shifted a little more, or it is more closer to the chlorine atom, and it is little farther from our hydrogen atom. So here we can see a partial charge, fractional charge, or sometimes it is also called as a charge separation. Charge separation means the charges are not integral values. They are not integers. They are fractional numbers of values less than 1. Why less than 1? Because if you gain 1 full electron, you get 1 full negative charge. But it has not gained any electrons. Remember, that's why it gets a partial charge. So based on this charge separation, we can make a few observations. We can actually distinguish the type of covalent bonds based on charge separation. So let us see what are the types of bonds based on charge separation. So when we talk about charge separation, we are talking about poles. So it's not a negative pole or a positive pole. These are poles, right? Usually for a magnet we say positive pole, negative pole, north pole, south pole. These are the polarity that we give it. So when exchange of electron has not taken place, a partial charge is created. So a polarity is created. So in a bond which is formed, what type of bond? Covalent bond. In a covalent bond where there is no charge separation. That means what? That means that the pair of electrons shared is in the center or is equally shared by both the atoms. There is no charge separation, there are no fractional charges, so there are no poles. So these type of covalent bonds are called as non-polar covalent bonds. Non-polar means they do not have any poles, they do not have any charge separation, they share the electrons equally. Coming to my polar covalent compounds, polar covalent compounds are those compounds which do have a charge separation. That means the shared pair of electron that we have is not equally shared. It is unequally shared. Alright, so we can understand that non-polar covalent bonds do not have any charge separation. Polar covalent bonds have a charge separation. Non-polar covalent bonds are usually formed between, सोचो जरा कि दो atoms है, why would they have charge separation? That we have defined electronegativity. If there is an electronegativity difference between two atoms in a covalent bond, then there is going to be some charge separation. That means जो ज़्यादा electronegative है, that will pull the pair of electron little bit closer to itself. So the more electronegative substance will get a fractional negative charge and the less electronegative substance will get a fractional positive charge. So there is a charge separation there. So when the atoms are such that they are atoms of the same element, for example chlorine combining with chlorine, एक ही element के atoms है, so they won't have any difference in electronegativity, isn't it? Difference in electronegativity is the thing that causes the charge separation. So if they are atoms of the same elements like chlorine-chlorine bond, oxygen-oxygen bond, these type of bonds, they share the electrons equally. They do not have any charge separation or polarity. So these type of bonds are usually non-polar covalent bonds. Carbon and hydrogen also has very low electronegativity difference, almost negligible. So for these cases, carbon and hydrogen also is a non-polar covalent bond, and a very good example where you can see that two atoms of two different elements are forming a non-polar bond. Alright, so and when we come to polar bonds, here we can see that you can see a fractional charge on either of the atoms. For non-polar you don't see a fractional charge because the electronegativity difference is low. Alright, this should be very clear to you. Polar means they have poles. There is a certain electronegativity difference, not very large. Why not very large? Because if electronegativity difference is very large, for example, metals and non-metals have a large electronegativity difference. So they will just exchange the electrons. Electronegativity difference एक range से जब ज़्यादा हो जाता है, then they end up giving electrons or taking electrons. But if there is a very small electronegativity difference, then they can't really take or give electrons, but they can pull, one of the atoms can pull the electron pair towards itself. And when there is no electronegativity difference, then both the atoms share the shared pair of electrons equally. So in that case, there is no pole, or the polarity does not exist. These are non-polar covalent bonds. Alright, so once again coming to electronegativity difference, क्या होता है? The electronegativity of one atom minus the electronegativity of other atom. So this electronegativity difference is what decides what type of bonds are formed between two atoms. So when electronegativity difference is negligible, that means it's less than 0.3. In those cases, non-polar covalent bonds are formed. Why? Because electronegativity difference is zero, almost zero we can say. So neither of them will pull the shared pair of electrons, so they will get no poles. When electronegativity difference is between 0.3 and 0.7, in that case, the type of bond is covalent, because still neither of the atoms are ready to give away electrons, but when they share it, the shared pair of electron is pulled closer to the more electronegative ion. So in this case, fractional charges are formed, and not just fractional charges, we can say poles are formed. So these type of covalent bonds are called as polar covalent bonds. And the last one, where electronegativity difference is more than 0.7, here it is very easy to actually give a whole electron, that or accepting a whole electron, that is getting a negative charge, or giving a whole electron and getting a positive charge. In this case, where electronegativity difference is more than 0.7, the types of bonds are ionic bonds, because here actual exchange of electron has taken place, where an electron is given by a metal and accepted by a non-metal. So these type of bonds are ionic bonds. Is that clear? So children, now we have seen that there are two broad types of bonds we have already seen, that is electrovalent bond and covalent bond. Covalent bonds again are of two types based on charges. Based on charge, we are just talking about the charge. What are the two types? Non-polar, which does not have any charge separation, and polar, which has charge separation. So let us once quickly compare ionic bonds, polar covalent bonds and non-polar covalent bonds. So when we talk about non-polar covalent bonds, there the shared pair of electron is equally distributed between two atoms. When we talk about polar covalent bonds or polar covalent compounds, in this the electron pair is unequally shared between two atoms. Why is it unequally shared? Because the more electronegative atom pulls the shared pair of electron little bit towards itself. And what happens in ionic bonds? Ionic bonds, full electrons are exchanged. So here electron pair sharing, all these, this does not come into the picture only. Why? Because a complete full electron, 1 electron, 2 or 3, maximum 3, remember, are exchanged. That means they are either given or taken. So for non-polar covalent bond, there is no charge separation because they are shared, the electron pair is shared equally by both atoms. In polar covalent bond, there is a slight charge separation. Why do we have a fractional charge separation? We have a charge separation because the electron pair is little bit skewed towards the more electronegative ion. Alright, and when we talk about ionic bonds or ionic compounds, here there is a proper full whole number charge which is present because electrons are fully given or taken. So here we can say true charges are present in ion, +1, -1, +2, -2, +3, -3 and so on. So they are full or whole number charges. So for non-polar covalent bond, charges between the atom is 0. No charge separation. For polar covalent bond, fractional charges like charges which are lesser than 1 is observed in the two atoms. So the one which is more electronegative will get a fractional negative charge. The one which is more electropositive will get a fractional positive charge. And when we talk about ionic bonds, we see whole number charges. Na plus combines with Cl minus. So Na plus 1 combines with Cl minus 1 to form a combine to form a compound. Ca2 plus 2 oxygen 2 minus. Proper whole number charges are present. Where whole number charges are present because whole electrons are exchanged. 2 electrons are exchanged in case of calcium oxide. So here we can say there are whole number charges present between the two ions. We can simply call them ions because they are now formed by the exchange of electrons, complete and true exchange of electrons. So in your 9th standard, you only have electrovalent bond and covalent bond, but in your 10th you will have coordinate bond. The only thing that you need to know about coordinate bond is a coordinate bond is formed. It's just like covalent bond where electrons are shared, but here the electron pair which is shared, let's say one covalency is 1, that is one pair of electron is shared. So in that case, that shared pair of electron is only provided by one of the atoms who has excess of electrons. Okay children, now we are going to see the formation of covalent bonds. Covalent bonds are bonds which are formed between two non-metals. That means it's a bond which is formed between two substances or two atoms. No one has given electrons, no one has taken electrons, there are no ions. Two atoms of same or different elements have come together and they have decided to share their electrons in order to complete their octet. So let us look at the examples. First we will will see the examples of bonds between similar elements. That means chlorine gas, oxygen gas, nitrogen gas, etc. Let us see. Formation of Cl2. So chlorine, now we know, has 287 electronic configuration. So each of these chlorine require one electron in their outermost shell. They have one and they require one. So neither of the chlorine is going to give away electrons, nor they are going to take it. So both will agree to share the electron. So chlorine, I will only draw the last shell, because when we show the orbital structure of covalent bonds, we are allowed to draw just the last shell. So chlorine's electronic configuration is 287. So I will only draw the valence shell, which is the shell which has only 7 electrons. 1, 2, 3, 4, 5, 6 and 7. And the other chlorine also has 7 valence electrons, isn't it? 1, 2, 3, 4, 5, 6 and 7. So now what happens is both of them require one electron each, so they will share one electron with each other. So they will share any one electron with each other. So what happens here is the electrons is now in the middle. Why? Because both chlorines have the same electronegativity. Neither of them can pull the shared pair of electron towards itself. So the electron will be in the center. That means the shared pair of electron will be at equal distance from both the chlorine atoms. That means it's a non-polar covalent bond. In fact, non-polar single covalent bond, because the covalency is 1. It only shares one pair of electron. So now can you see? If you look at this, chlorine has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its last shell. And this chlorine also has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its last shell. So by this small adjustment, they can have a complete octet even without exchanging their electrons. Now let us look at oxygen. So here first, before oxygen, let us draw the dot structure of chlorine. So chlorine will be in single bond with another chlorine atom, and it will have 1, 2, 3, 4, 5, 6, 7. This will also have 1, 2, 3, 4, 5, 6 and 7 atoms of its own, 7 electrons of its own, and 2 of them will be shared. So what will be the dot structure? Simply Cl-Cl. Coming to oxygen. That is O2. Now oxygen's electronic configuration is 2, 6. So it requires 2 electrons to complete its last shell, or to complete its octet state. So what is the covalency of oxygen? It is 2. So how many pairs of electrons will be shared? 2. How many total number of electrons will be shared? 2 pairs. So total 4 electrons will be shared. So let us draw the last orbit of oxygen, which has 6 electrons in itself. So it has 6 electrons, 1, 2, 3, 4, 5 and 6. Same for the next oxygen. 1, 2, 3, 4, 5, 6. How many will it share? This is one pair and this is the other pair. So how will it look now after this pairing, after the sharing has happened? And again, let me repeat, oxygen, both of them are oxygens. Remember this. So it's going to be a non-polar covalent bond. In fact, it will be a non-polar double covalent bond. That's the complete name of the bond. So oxygen will look something like this. 1, 2, 3, 4. 2, 3, 4 and 1, 2, 3, 4, and other 2 are shared. So 1, 2, 3, 4 are shared, correct? So what will be the electron dot structure look like? It will look like this. Let's come to nitrogen. This is also N2. Now nitrogen's electronic configuration is 2, 5. So how many electrons does it require to complete its octet state? It requires 3 electrons to complete its last shell. So let us draw the last shell, nitrogen. The last shell has 1, 2, 3, 4, 5 electrons, and the other nitrogen also has 1, 2, 3, 4, 5 electrons. So it will form 3 pairs, correct? So nitrogen will form a triple covalent bond. And what type of triple covalent bond will it be in terms of polarity? It will be a non-polar triple covalent bond. Last non-polar compound, which is a very good example of two elements of different substances, two different elements coming together to form a non-polar compound. Methane, CH4. Now carbon and hydrogen are two different elements, but they are very close to each other when it comes to their electronegativity. That means they both have very similar tendency of pulling the electron pair towards themselves, or they have the same very close tendencies of becoming an anion, you can say. So their electronegativities are very close to each other. So the type of bond formed here is also non-polar covalent bond. Let us look at the structure. So I will only draw the outer shell. So carbon's electronic configuration is 2, 4. Hydrogen's electronic configuration is 1. This is clear for all of us. So carbon requires 4 electrons in its outermost shell, which it will share with 4 hydrogens, because each hydrogen requires 1 electron in its outermost shell, and 1 carbon requires 4 electron in its outermost shell. This is my carbon atom. I am just drawing the last shell. The last shell has 4 electrons. It requires 4 more to complete its octet. So where will it get these 4 electrons from? It will get 4 electrons from 4 hydrogen, because hydrogen requires only 1 electron to complete its what state? Duplet state. I hope you remember hydrogen and helium are an exception. They can be stable by duplet state. That means by 2 electrons in its last shell. So coming to my hydrogen. So hydrogen has 1 electron each. So what will happen over here? They will share like this. Can you see this? This is the formation of methane. So how will you draw the Lewis dot structure or the electrons dot structure? Simply like this. This is your electron dot structure, and this is also a non-polar covalent compound, where now there is another very good question that comes in your exam. What is the you can say, what is the covalency of methane? That question is completely invalid. Covalency can only be determined between 2 atoms, any 2 atoms. It cannot be determined for the whole compound. Here there were only 2 atoms, so we could say that there is the covalency is 1, 2 or 3. Here there are 5 atoms. So covalency can only be determined between carbon and hydrogen, which is 1. This carbon and this hydrogen, which is also 1. This carbon and this hydrogen, which is also 1. And this carbon and this hydrogen is also 1. So the covalency cannot be determined for the whole compound. You can't say the covalency is 4. That's not correct. Covalency can only be determined between 2 separate, only 2 atoms. Is that clear? Alright, now we will move on to the polar covalent bonds, the polar covalent compounds. Now let us look at the structure or the molecule of polar covalent compounds. The 2 main polar covalent compounds that we are going to be studying is water. It is very important to understand the structure of water and of ammonia. Alright, so let us start with water. As you can see, H2O, that means there are 2 atoms of hydrogen and 1 atom of oxygen. So this 1 atom of oxygen requires how many electrons to become an octet? 2 electrons. electrons, and hydrogen requires 1 electron to complete its duplet. That means to become stable, oxygen requires 2 electrons, each of hydrogen requires 1 electron each, and they cannot exchange the electron because neither hydrogen nor oxygen are capable of giving electrons. So they will do it by covalent bonds between them. That means by mutual sharing of these electrons. Let us see. So oxygen two, comma 6. I have also drawn the first shell here. Alright. Coming to hydrogen. Hydrogen has only 1 electron. Each of hydrogen has only 1 electron. So how will they satisfy their octet or duplet state? Oxygen will share 1 electron with this hydrogen and oxygen will share 1 electron with this hydrogen. So let us look at the oxygen atom in the cloud. Oxygen now has 1, 2, 3, 4, 5, 6, 7, 8. Can you see that? 1, 2, 3, 4, 5, 6, 7 and 8. What about hydrogen? Hydrogen has 1 and 2. This hydrogen also has 1, 2 electron in its last shell. But this bond, oxygen and hydrogen, have a large electronegativity difference between them. So this electronegativity difference between them is large enough to bring a polarity. That means bring a partial charge. What is the partial charge? What does it mean? It means that oxygen and hydrogen, when they are sharing their electrons, the electron pair will be closer to oxygen and will be away from hydrogen. So when electron is closer to oxygen, that means oxygen has more negative charge towards itself, but it is less than that of 1 complete electron. That means by taking 1 complete electron, I get 1 negative charge. But when I am sharing an electron which is closer to me, I only get a partial charge or delta charge. So complete exchange of electron has not taken place. Only thing is the electron is closer to me. So it is not giving me a full charge, but it is giving me a delta charge, a fractional charge. Alright. So oxygen will have delta minus charge. Do you know this? I have explained this to you. Oxygen will have a negative charge and hydrogen will have positive charges. But these are not whole number charges. These are fractional charges lesser than 1. This charge does not mean same as the charge that is obtained by taking electrons, because when you take electron you get a 1 full charge, 1 integral value charge. But when you are sharing electrons but the electrons are closer to you, you get a fractional charge, a very partial charge. Alright. So oxygen and hydrogen, this is how they share their electrons. And how do you draw the Lewis dot structure? Okay, this is not the complete structure. Here you also have to draw. Oxygen has shared how many electrons? Oxygen has shared 2 of its electron with 1 each of hydrogen. And how many are remaining over here? There are 4 electrons. So how many pair of electrons are present right now with oxygen? 2. So 1 pair over here, 1 pair over here, and 1 is shared. This is the Lewis dot structure of H2O. Alright. Coming to our next compound, which is ammonia. NH3. Again, nitrogen and hydrogen have a significant electronegativity difference. That means nitrogen has a tendency to get the shared pair of electron closer to itself. Hydrogen does not have such a strong tendency. So again, nitrogen will get a partial negative charge, hydrogen will get a partial positive charge. Alright, let us see how the structure will look. So nitrogen's electronic configuration is 2, 5. How many electrons does it need to complete its octet? 3. How many electrons does hydrogen need? Each of hydrogen needs 1 electron. So each hydrogen will share 1 electron with nitrogen. Alright? So nitrogen has 2, 5. Okay? Hydrogen has 1 electron. So each of the hydrogen will share 1 electron with nitrogen. Is that clear? And nitrogen is left with 1 pair of extra electrons. Do not forget it. So this pair is called as the lone pair. What is it called? Lone pair. So how will you draw the electron dot structure here? Nitrogen, hydrogen, hydrogen, hydrogen. Is that clear? This is the electron dot structure of ammonia.